So the seventh problem you are given with is x of n is equal to a power mod n. Now, how do we define this is x of n is equal to a power minus n for n less than 0 and it is equal to a power n for n greater than or equal to 0. This is how we split the mod function. We know this. We know the working of mod function. For negative values of n, it will be a power minus n. So that if you give negative values also, negative values of n, if you give, it will become positive. That means you will get a symmetric curve because you have a modulus sign here. Symmetric curve about y-axis. Now, how do you find DTFT of it? X of e power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega n. Now I need to split this summation for negative values of n as well as positive values of n. So I will split this summation as n is equal to minus infinity to minus 1 x of n e power minus j omega n plus, see, on a number scale, if I take it from minus infinity, so if it is 0 and this is infinity, this is minus 1, this is 1, minus 2 and so on. So if I sum it from minus infinity to minus 1, then I need to sum it from 0 to infinity, or because these are negative values and these are positive values of n. So minus infinity to minus 1 and summation n is equal to 0 to infinity x of n e power minus j omega n. Now, what is x of n? For negative values of n, it is negative values because n is equal to minus infinity to minus 1. It is a power minus n. So, summation n is equal to minus infinity to minus 1 a power minus n e power minus j omega n plus summation n is equal to 0 to infinity. What is x of n for positive values of n? It is a power n into e power minus j omega n. Now this summation can be written directly. So this is summation n is equal to 0 to infinity a e power minus j omega power n. This is summation n is equal to 0 to infinity alpha power n form. It is 1 by 1 minus this term. But here we do not have a standard summation of a GP till of infinite terms. So we need to convert this summation from 0 to infinity. Now first of all, what you do is, I need to have infinity in my upper limit. So I'll change my limit, that is n is equal to minus 1 to minus infinity a inverse e power minus j omega power n I'll be getting. Now this summation will not alter because it is of the direct form. Summation n is equal to 0 to infinity alpha power n. This summation I need to alter. Now I need to get plus infinity. So what do I do? Put n is equal to minus n in first summation, because the second summation I am keeping it as it is because it is in the standard form. So if I put n is equal to minus n, summation n is equal to 1 to infinity I will be getting. So the upper limit is changed to, upper limit of the summation is changed from minus infinity to infinity because I have substituted n as minus n. So I will be getting a power minus 1 e power minus j omega power minus n plus the second summation I will keep it as it is, a e power minus j omega power n. I had to rub this off because I didn't have enough space there. So the last equation or the format what we got at the end was this. So it is this, the second summation I am not altering, it is, I am keeping it as it is because it is in the standard form. Now I have converted my upper limit, which was from minus infinity to infinity, by putting n is equal to minus n. Now I need to convert my lower limit to 0. How do I do that? When n is equal to 1, I substitute n minus 1 as some other variable m. So from this, n is equal to m plus 1. So I'll be getting, when n is equal to 1, when n is equal to 1, m is equal to 0, and when n is equal to infinity, m is equal to infinity, because infinity minus 1 is nothing but infinity, and when n is equal to 1, 1 minus 1 is 0. So m is equal to 0 till infinity. I'll be getting a inverse e power minus j omega power minus, what is n? It is m plus 1, plus summation n is equal to 0 to infinity a e power minus j omega power n. Now this is converted into the standard form m is equal to 0 to infinity a power minus 1 e power minus j omega power minus m into a inverse e power minus j omega power minus 1. So I can split this into 2 because I have m plus 1 as a power. So summation n is equal to 0 to infinity a e power minus j omega power n. Now the summation is on m, so this term is a constant, so I can take it out. So what it will be is a power minus 1 into minus 1, it is a, into e power minus j omega into minus 1 is e power j omega. So that is what I get. Now summation m is equal to 0 to infinity. If I multiply by minus 1, I will be getting a e power j omega power m plus summation n is equal to 0 to infinity a e power minus j omega power n. So it is a e power j omega divided by, what is the summation from m is equal to 0 to infinity alpha power m? It is 1 by 1 minus alpha. It is 1 by 1 minus a e power j omega plus, this is direct, 1 by 1 minus a into e power minus j omega. So this is the final discrete time Fourier transform of a power mod n. So we can still further simplify by taking the common denominator, and we'll get the further reduced equation, but you can keep it at this point as well, because you'll be getting the first DTFT of the term by summing up from minus infinity to minus 1 and then from 0 to infinity. Now in this problem, x of n is given to be alpha power n sin omega naught n u of n. Now we know the Fourier transform of, discrete time Fourier transform of alpha power n u of n. Right. So I can rewrite this as sin omega naught n alpha power n u of n, which in turn I can write it as sin in terms of exponential, it is e power j omega naught n minus e power minus j omega naught n divided by 2j into alpha power n u of n. So if I take 1 by 2j as a constant, it is e power j omega naught n into alpha power n u of n minus e power minus j omega naught n alpha power n u of n. This is what I get. This is x of n, and this is my final x of n. Now what is the DTFT of alpha power n u of n, which we have already solved? It is 1 by 1 minus alpha e power minus j omega, and I have also told this is the standard signal whose DTFT must be known to everyone. Now we have a property called frequency shift. It is e power j omega naught n into x of n. The DTFT is x of e power j into omega minus omega naught. So if you have any doubt regarding this, please visit the video. Please have a look into my video of properties of DTFT. So if there is an exponential multiplier to the input, the Fourier transform of it gets shifted by that exponential multiplier's omega term. So what we need to know is what is x of e power j omega, then shift it accordingly. So here this is the exponential multiplier and this is my x of n. This is exponential multiplier and this is my x. I can take x1 and x2 since x1 is present already here. So taking DTFT, I will be getting x of e power j omega is equal to 1 by 2j into alpha power n u of n. The DTFT is 1 by 1 minus alpha e power minus j omega. So 1 by 1 minus alpha e power minus j into omega. Omega will be shifted by its exponential factor. So what is exponential factor here? It is omega naught. So omega minus omega naught minus again alpha power n u of n. It is 1 by 1 minus alpha e power minus j into omega plus omega naught, because the factor what you have here is minus omega naught, here you have plus omega naught. So this is the DTFT of the given function alpha power n sine omega naught n u of n. So only the difference is you convert sine function into exponential functions and use that exponential function as in frequency shift property. So frequency shift property is exponential multiplied by input gives the Fourier transform shifted by the frequency term. So the frequency term here is omega naught. So x1 of n is alpha power n u of n. So its Fourier transform is, that is 1 by 1 minus alpha e power j omega, and that omega will be shifted by omega naught because you have exponential multiply. Now in this problem you are given with x of n which is having an amplitude of 1 at minus 3 and minus 2 and amplitude of 1 at 2 and amplitude of minus 1 at 3. So we need to find DTFT. So from the basic, x of e power j omega is equal to summation n is equal to minus infinity to infinity x of n e power minus j omega n. Now where is my x of n existing? It is existing only for values of n which is minus 3, minus 2, 2 and 3. So my summation would be x of minus 3 into e power minus j omega into minus 3 plus x of minus 2 into e power minus j omega into minus 2 plus x of 2 e power minus j omega into 2 plus x of 3 e power minus j omega into 3. This is just the expansion of this summation. Summation is from minus infinity to plus infinity, but for what values of n, x of n is valid? Valid as in it is having the amplitude that I have written. So it is x of n is having its value only at minus 3, minus 2, 2 and 3. So that value of n I have substituted minus 3, minus 2, 2 and 3. So what is the value of x of minus 3? X of minus 3 is 1. So it is e power j omega into 3. X of minus 2 is also 1. So e power j omega 2. X of 2 is 1 again. So e power minus j omega 2. X of 3 is minus 1. So minus e power minus j omega 3. So if I combine these two, if I combine e power j 3 omega minus e power minus j 3 omega plus e power j 2 omega plus e power minus j 2 omega, and if I divide this by 2j, I need to multiply here by 2j as well, and if I divide this by 2, I need to multiply here by 2. Now why did I do this is to convert this into a standard form. What is sine theta? It is e power j theta minus e power minus j theta by 2j. That is why I divided by 2j and multiplied by 2j. because you have a negative sign in sin theta, whereas in cos theta it is e power j theta plus e power minus j theta by 2. So that is why I multiplied here by 2 and divided by 2. So what I will be getting is 2j into sin 3 omega plus, because j theta is 3 omega, plus 2 into cos 2 omega. So this is my x of e power j omega of the given signal, which extends which is present at -3, -2, 2 with the amplitude of 1, and at 3 amplitude of -1. Now in this problem my x of n is defined to be delta of 4 minus 2n. Now we need to know where this function is existing. We already know that what is delta of n. It is an impulse function which is having an amplitude of 1 at n is equal to 0. Now here you have many operations to be done. The first one is the shifting operation, then scaling operation, then reflection. So the first operation is I need to perform n plus 4. So it is delta of n plus 4. Now what is delta of n plus 4? It is shift left of this sample by 4. So which was at 0 will go at -4. So amplitude is 1 and which will be present at -4. So delta of n plus 4 we have done. This is n plus 4 because there is plus sign here, n plus 4. Now next you have scaling by 2. Scaling by 2 means if you have a whole multiplication by 2, my spectrum will, my signal will get compressed, and if you have divide by 2 it will get expanded. Now you have multiplication by 2, so it is delta of 2n plus 4. That means my waveform will get compressed. The sample which was present at -4 will come at -2. So the same sample will come at -2. Now what I have here is 4 minus 2n. That means I need to take the reflection of it. So what I will be getting is delta of -2n plus 4, which is same as 4 minus 2n. So I need to take the reflection. Reflection means it will go to +2 with an amplitude of 1. So this is my final waveform. It is delta of 4 minus 2n. So it is having an amplitude of 1 at 2. So the DTFT of which is summation n is equal to -infinity to infinity x of n e power minus j omega n. But x of n, which is delta of 4 minus 2n, is existing only at n is equal to 2. So this will be e power minus j omega n at n is equal to 2. So because this summation of n from -infinity to infinity is valid only at n is equal to 2. So e power minus j omega into 2. So this is the final answer, that is DTFT of delta of 4 minus 2n. So in this problem x of n is given to be 1 when magnitude of n is less than or equal to m and 0 otherwise. Now how does my x of n look like? If this is my x of n and this is my x-axis, magnitude of n is less than or equal to m. Now mod n means what? It can take positive values as well as negative values. So mod n means n, this axis is n, so it can have values less than m. So less than m, positive side, and to the left I have minus m. So x of n is 1 from minus m to plus m. So it is having the amplitude of 1 everywhere from minus m to plus m. So all the amplitudes are 1. So you can write it here 1, 1, and everywhere it is 1. So I need to find DTFT of this. X of e power j omega is n is equal to -infinity to infinity x of n e power minus j omega n from the basics. Now where is my x of n valid. It is present only between minus m to plus m, right? So I can rewrite my summation as n is equal to minus m to plus m into x of n. What is the value of x of n from minus m to plus m? It is 1. Everywhere it is 1 into e power minus j omega n. So summation n is equal to minus m and till m e power minus j omega power n. Now I have two standard formulae for summation, that is n is equal to 0 to infinity alpha power n is 1 by 1 minus alpha. This is sum till infinity of a GP. Then one more is summation n is equal to 0 to n alpha power n. It is 1 minus alpha power n plus 1 divided by 1 minus alpha. See, this n will be added by 1. I mean, this is also a GP but till finite term, whereas here till infinity, that means it will have infinite terms. So these are the two standard formula I have. As you can observe here, in both the summations the lower limit is 0, right? So I would like to convert the summation into that form. So how do I make the lower limit 0? So it is n plus m is equal to some other variable. I will take small n. Okay, this is small n, capital M and small n. Now when the lower limit, when n is equal to minus m, so if you substitute minus m here, m will be 0. Then when n is equal to plus m, m will be 2m. So my summation, this summation will change to summation m is equal to 0 because the n plus m is replaced by m. So the summation limit will be changed to m. M is equal to 0 to when n is equal to capital M is equal to 2m. So I get 2m into e power minus j omega. What is n from here? N is equal to m minus m. So I'll be getting m minus capital M. Now the summation is on small m, so e raised to the power capital M is a constant, so I can take it out. So it will be e minus and minus, so I'll be getting plus. So it is e power j omega m summation m is equal to 0 to 2m e power minus j omega power m. Now this would be e power j omega m. This is the term which I have got by converting these two terms. Okay, you can, if you have not understood, I'll write it this way: m is equal to 0 to 2m e power minus j omega m into e power j omega capital M. So this e power j omega capital M, I have got it out into, what is the summation? 0 to 2m, that means of finite terms. So it will be 1 minus alpha to the power n plus 1. What is n here? 2m. So it will be 1 minus, what is alpha? E power minus j omega power m plus n, n plus 1. What is that? 2m plus 1 divided by 1 minus alpha. Alpha is e power minus j omega. So this I can write it as e power j omega m into 1 minus e power minus j omega into 2m plus 1 divided by 1 minus e power minus j omega. This is what I get. Now if I rearrange the terms by taking half of this out and half of this out, that means exponential raised to the power, I am taking half of it out. That means I am taking e power minus j omega 2m plus 1 divided by 2. If I take it out, what I'll get here is e power j omega 2m plus 1 by 2, because minus j omega 2m plus 1 by 2 into j omega 2m plus 1 by 2, it will be e power 0, that will be 1, minus half of this I have taken it out, so what you get is e power j omega into 2m plus 1 by 2. So this is what I get in the numerator. Now if I take half of e power minus j omega, that is half of e power minus j omega by 2 out, what I will be getting here is e power j omega by 2 minus e power minus j omega by 2. E power j omega by 2, because e power j omega by 2 into e power minus j omega by 2 is 1. E power minus j omega by 2 into e power minus j omega by 2 is e power minus 2j omega by 2. It is e power minus j omega. So if I simplify this, e power j omega m into, if I split this, I will be getting e power minus j omega into 2m divided by 2. 2 gets cancelled, so I get e power minus j omega m. E power minus j omega m into e power minus j omega into 1 by 2. So it is e power minus j omega by 2 divided by, I have e power minus j omega by 2 into this entire term will come here. Now what is this term? It is e power j theta minus e power minus j theta, and here also I have e power j theta minus e power minus j theta. So if I divide the numerator by 2j and divide the denominator by 2j, it will not change the values. So what it will be? This value is e power j theta minus e power minus j theta divided by 2j. It is sine of that. So it will be sine of theta. What is theta? Omega by 2 into 2m plus 1 divided by this, also you get sine omega by 2. Whereas here e power j omega m into e power minus j omega m is e power 0, cancel. This term and this term gets cancelled. So finally what I will be getting is x of e power j omega is only this factor, that is sine omega by 2 into 2m plus 1 divided by sine omega by 2. Now the thing to be remembered here is, if you have we have seen a CTFT, the CTFT of a rectangular pulse between minus t to plus t. If this is CTFT, my CTFT x of j omega was a sinc pulse. That means a Fourier transform of a continuous time signal is a sinc pulse. So this is a rectangular pulse with amplitude of 1 sweeping between minus t to t. I have solved this problem. If you have any doubt, you can go back to CTFT problems and check this. So the rectangular signal Fourier transform was sinc signal. Here also I have a rectangular signal which sweeps from minus m to plus m. So I have got the DTFT of which as sine omega by 2 into 2m plus 1 divided by sine omega by 2. It is a sinc pulse again. So remember this thing, this fact, that the Fourier transform of a rectangular pulse is a sinc pulse. This is also a rectangular pulse. You have got sinc pulse. And inverse Fourier transform of a rectangular pulse is again a sinc pulse. So this problem I have solved in inverse Fourier transform of CTFT. So if you have any doubt, please look into it. So this is the DTFT of the signal, rectangular signal, which extends from minus m to plus m. Now in order to plot it, x of e power j omega with respect to omega. See, at omega is equal to 0, I will be getting, this is omega axis, at omega is equal to 0, sine 0 divided by sine 0. So this will be undefined. I mean, it is undefined. So what you do is you use a famous rule called L'Hospital's rule, and which says that you differentiate the numerator and differentiate the denominator. So if you differentiate the numerator, it will be cos omega by 2 into 2m plus 1, and differentiation is with respect to omega, so you get into 2m plus 1 by 2 divided by cos omega by 2 into half. So this half and gets cancelled with this half. Now if I substitute omega is equal to 0, you get cos 0 by cos 0. Cos 0 is 1. So what do I get is 2m plus 1. So this is the amplitude at omega is equal to 0. So at omega is equal to 0, the amplitude is 2m plus 1. Now you know that it will be a sync pulse. So the amplitude at omega is equal to 0 is 2m plus 1. This is a generic question. In specific, if m is specified as 6, say for example x of n is 6, m is specified to be 6, that means it extends from minus 6 to plus 6. So samples minus 5, 4, minus 4, minus 3, minus 2, minus 1, 0 until 6. All the samples are 1. So if this is the specific case, then the amplitude here is 2 into m. M is what? 6 plus 1, that is 13. Now where do you get the first zero crossing? So the zero crossing is possible when you get pi, sin pi. Sin pi is 0. So for what value of omega you get sin pi? It is if omega is equal to 2 pi by 2m plus 1. If I substitute omega as 2 pi by 2m plus 1, 2m plus 1, so it will be sin omega. Omega is 2 pi by 2m plus 1 into 2 into 2m plus 1. So it will cancel here. So you get sin pi. So this is the lowest value of omega for which sin will go to 0. So this value is 2 pi by 2m plus 1, and the value on the negative side is minus 2 pi divided by 2m plus 1. So this is a general problem which I have solved, which exists for a signal which exists from minus m to plus m. So m value may be specified. I have taken a case wherein it was 6, it may be 7, 8, and appropriately the value will be changing here. Now this sync pulse starts at 0 and this will repeat itself because DTFT is periodic with period 2 pi. So sync pulse which is present at 0 will have its amplitude at 2 pi because it is periodic with period 2 pi, and again to the left it will be sync pulse again here at minus 2 pi. That is why my DTFT of any signal is periodic with period 2 pi. So the proof for which I have given in the very first problem, so you can look into it. The DTFT of any discrete time signal is periodic with period 2 pi. So that is why this sync pulse repeats after 2 pi. So I have solved many number of problems under finding the DTFT of a discrete time signal. Hope this will be useful for you. Thank you for watching.